So let's continue where we left off with adding and subtracting equations. We tried ones where they were addition equations and we had to subtract on both sides. Now we are going to see the opposite. We're going to see subtraction equations where we're going to end up adding on both sides. I'll zoom in a little bit more on this guy. So this one says t minus 5.8 equals 16. We still want to get the variable by itself, that t by itself. What's in the way of that? This minus 5.8. We've got to get rid of minus 5.8. Well, how do you get rid of or undo minus 5.8? We add 5.8. Minus 5.8 plus 5.8, isn't that just 0? Goes away, see ya. And all we have left on the left-hand side is t. But we know whatever we do to one side, we have to do to the other. So over here we have 16 plus 5.8. What's that going to give us? 16 plus 5 is going to be 21 plus the 0.8. 21.8. That's what I believe my solution is. To check it, where do I go? Back up into this original equation, and I'm going to plug in my t for that t and see if it works. So I'm going to plug in 21.8 minus 5.8 equals 16, question mark. That's what I want to know. Get the handy-dandy calculator. 21.8 minus 5.8, what does it give me? Woohoo, 16. Does 16 equal 16? Absolutely. So that's our solution for this one. Okay, let's try it down here. Show what you add on both sides of the equation to undo the subtraction. And we're going to check our solutions. So on this one, I'm going to put my line for my equal sign just so I make sure I do things on both sides of the equation. I'm trying to get the n by itself. I want n equals something. So what's in my way of having the n by itself? Minus 11. How do I undo minus 11? Do the opposite and we add 11. And we have to do it to both sides. So on this left-hand side, minus 11 plus 11. Bye-bye. See ya. Bring down what's left. N. Bring down our equals. And what's 14 plus 11? 25. You got it. And to check it, we go back to our original equation right here and plug in 25 for n. So let's see, 25 minus 11, does that equal 14? Well, can't do anything to that 14. Let's see what 25 minus 11 is. Just be sure. Even though I know in my head 25 minus 11 is 14, I'm going to be 100% sure that my brain isn't playing any tricks on me. And 14 equals 14. Okay, 4, 5, and 6. Let's do a Sage and Scribe for number 5 and number 6. Let's see if we can Sage and Scribe this one. Number 6 has some fractions in it. You will have to find a common denominator for those, but they're not too bad. Those denominators aren't too rough. So we'll come back in just a second and see what you came up with. All right. Did we get s by itself for this one? S was on the right-hand side of the equal sign. That doesn't matter. We're trying to get rid of the minus 3.5. So how do we get rid of minus 3.5? Add 3.5. See ya. Bye-bye. We bring down our s. We bring down our equal sign. Negative 2 plus 3.5. Negative 2 plus 3.5. That's going to get me up to the positives. It's going to be positive 1.5, I think. And I'll be able to check it and make sure. To check, we go back to that original equation up there. We've got negative 2. Does that equal, here's my s, 1.5 minus 3.5, question mark. Grab the calculator. 1.5 minus 3.5. What does it give me? Negative 2. So I get that negative 2 equals negative 2. Woohoo, I was right. Number 6, same idea. You're trying to get the x by itself. Here's our equal sign. To get rid of the minus 3/4 that's next to the x, you have to add 3/4. So I'm going to add 3/4 to both sides. Minus 3/4 plus 3/4 goes bye-bye. That was the point. Bring down our x. Bring down our equals. Now this. To be able to add 1/2 and 3/4, we have to have a common denominator. Could I just turn the half into fourths? What would I do for this? Could I make this times 2 times 2? What's my new fraction here? That's going to be 2/4 plus 3/4. And I'll just write it out like that so I can see it a little better. Bring down my x equals, what is 2/4 and 3/4? Doesn't that give me 5/4? And if I wanted to simplify that, I could turn it into mixed number. How many times does 4 go into 5? 1 and 1/4. So that's what I believe my solution is for this one, 1 and 1/4. Let's plug it back in. Let's check it and see. Go back to the original equation. So x, 1 and 1/4 minus 3/4, does that equal 1/2? Question mark. To be honest, these fractions are easy enough that I can just put them into decimals pretty quickly and check it with a calculator. 1 and 1/4, if you don't have 1/4 memorized, you need to. 0.25. 3/4, you should know that's 0.75. 1/2, 0.5, right? Can I check this and see? 1.25 minus 0.75. Look at that. 0.5 equals 0.5. Woohoo. Could I have left those as fractions and actually done the subtraction and found out if it equaled 1/2? Sure. Sometimes it's faster as a calculator using decimals if they're easy decimals. All right. Last thing, let's see how we are going to actually write our own equations. Because it's all well and good to be able to do these, but in real life you're not just going to walk into a grocery store and they're going to hand you n minus 11 equals 14, solve this. No, but in real life you're going to have situations where you will come up with equations like these to solve. Right? This particular one right here, I hope you could figure it out without having to write an equation, but we're going to try an equation with these numbers because I think it's a good example for you to realize that it's not too hard to write the equation. You're flying a kite. The total length of the kite string is 275 feet. How much string have you let out so far? So is flying the kite if you have 153 feet of string left on your roll. We want to write an equation with a variable. So the hint is to use S for the length of the string that we have let out because that's what we want to figure out. We want to know how much have we let out so far. Can we use a verbal model to kind of describe the situation? You've got some string on a roll, plus you've got some string that you have let out, and that's going to be what? The total amount of string that you're using. Could we put that together with the numbers? So we've got string on a roll. How much is left on our roll? 153 plus the string that we already let out of the roll. What do we? That's S, right? We don't know that. Equals the total amount of string, which was, whoops, 275 right here. Okay, 275. Is that an equation? Yeah, absolutely. Okay. Now there are other ways that we could write this. We could write it as, let's see, could we do the total 275 minus how much is let out? And that would give us 153. Yep, we could do it that way. What we want to stay away from is something like this. 275 minus 153 equals S. Is that true? Is that the case? That 275 minus what was left, 153, gives us what we let out? Yeah. But in that case, it's not an equation where the variable has something going on with it. This is more like an expression where you could just simplify it and get your answer. We don't want to write our own equations where there's an equal sign and just a variable by itself. Okay? Now you will see that this is going to end up being what we do when we solve this equation over here. So for now, let's just use this one. Let's use this first one and try and solve that guy. Okay, I'm going to rewrite it down here so we can see my 7 better. 275, there we go. How do we get the S by itself? We get rid of that 153. Now that 153, there's no plus in front of it, right? But isn't it just a positive 153? It's being added over here. So 153 minus 153, see ya. Goes away, goes to 0. Whatever we do on one side, we do on the other. S equals, and here's where we get that 275 minus 153. 122. 122 what? What are we talking about here? 122 feet, isn't it? Feet of string. So feet is good enough for now. Now, would we be able to go back and plug that into the original equation and check it? Yes, I would expect that you could do that. At this point, it was more for practice writing the equation like this. I think you're good. Nice job.